So here we are going to use substitution to evaluate integrals. The first set of problems involves indefinite integrals, and then we'll move on to definite integrals. So here what I'm going to do is I'm going to make my u to be square root of x plus 1, which means my du is 1 over 2 root x dx. So then I go here. So then I'm going to, the whole thing, my numerator is become u to the power of 4, and dx over root 2x is my du. So this is my integral. I take the integral, I have this as my answer. Then I substitute back. My u was square root of x plus 1 to the power of 5 over 5 plus c is my final answer. So again, here I'm going to make my u 10x minus 3. So my du will become 10 dx. But I don't have 10 dx, I only have 1 dx. Therefore, I divide on both sides by 10. So this can be written as 1 over 10 du over u squared, okay? Which is nothing but u to the power of negative 2 du. So this is u to the power of negative 1 over negative 1 plus c, which is negative 1 over 10u plus c, which is negative 1 over 10 times 10x minus 3 plus c. Okay. Okay, so here I'm going to make my u to be sine theta. So my du will be cosine theta d theta. So my original integral becomes u to the power of 10 du. So this is u to the power of 11 over 11, and which is sine to the power of 11 theta over 11 plus c is my answer. Here I'm going to make my u to be x to the power of 10. So du will be 10x to the power of 9 dx. Okay, but I only have x to the power of 9 dx in my problem. So I had to divide both sides by 10. So when I substitute, this x to the power of 9 dx becomes du over 10, right? So that over 10 goes outside. Then this one can be written as sine u. So then this becomes negative cosine u. So this is negative 1/10 cosine u plus c, which is negative 1/10 cosine x to the power of 10 plus c. You can always check by differentiating. Okay. Okay. Here my u will be 1 plus 4x square. My du will be 8x dx, but I only have an x dx, so I'm going to divide by 8. So this will become 1/8 du over u cubed. So this can be written as 1/8 u to the power of negative 3 du, right? So this is 1/8 u to the power of negative 2 over negative 2. So which is negative 1/16 u squared plus c, which is negative 1 over 16, 1 plus 4x squared, the whole squared plus c. So here I'm going to make my u to be just 4w. So that means du is 4dw. So dw is du over 4. So this is 1/4 secant u tan u du. And this is nothing but secant u plus c, which is 1/4 secant 4w plus c. Okay, so here I will make my u to be cosecant x. So my du is, what is my du? Negative cosecant x cotangent x dx. So this can be split up as cosecant cubed x times, right? Cosecant x cotangent x dx, correct? So then this becomes negative u cubed du. Okay, so then it is negative u to the power of 4 over 4 plus c, which is negative cosecant to the power of 4x over 4 plus c. Okay. Okay, here I'm going to make u to be sine x. Du is cosine x dx. So then this becomes u to the power of 5 plus 3u cubed minus u du, which is u to the power of 6 over 6. Okay. So then my u is sine x. So I have sine to the power of 6x over 6 plus 3 sine to the power of 4x over 4 minus sine squared x over 2 plus c as my final answer. Okay, here my u will be x to the power of 3 halves plus 8. My du will be 3 halves x to the power of 1 half dx. But I only have x to the power of 1 half dx. So I will have to multiply both sides by 2/3. Okay, so then this will become u to the power of 5 du, but the 2/3 will go here. So then I have 2/3 u to the power of 6 over 6 plus c, which is 1 over 9, x to the power of 3 halves plus 8, the whole thing to the power of 6 plus c is my final answer. Always check by differentiating if you're not sure, okay? So now here my u is going to be square root of t. My du will be 1 over 2 root t dt, but I only need 1 over root t, right? So I'm going to multiply both sides by 2. So 2 du is 1 over root t dt. So this can be written as cosine u. So dt over is 2 du, right? So du, and then the 2 can go outside. Okay. So now this is 2 sine u plus c. And what was u after all? U is square root of t, right? And that is my answer. Again, check by differentiating if you have any doubts. Okay, so here I'm going to make u to be secant x. So then my du will become secant x tan x dx. So my this integral can be written as, I can take a secant x as a common, right? So this will become secant to the power of 4x plus secant squared x times secant x tan x dx. So this can be written as u to the power of 4 plus u squared du. So this will be u to the power of 5 over 5 plus u cubed over 3 plus c, which can be written back at as secant to the power of 5x over 5 plus secant cubed x over 3 plus c. Now we are going to do the same substitution method on definite integrals now. Okay, so this is nothing but sine 2x over 2 between the limits 0 to pi over 2. You can always check what is the derivative of this. The derivative of this will be cosine 2x times 2, correct? So that's how I got this. Okay, so then I substitute. I get 1 half sine pi over 4 minus 1 half sine 0. So sine pi over 4 is root 2 over 2. So I have root 2 over 4 as my answer. Okay, so here my u, okay. Actually, what I can do here is I don't have to, okay, I can do a u, or I can actually do I can distribute it, but let me do a u. U is 4 minus x squared. So du is negative 2x dx, but I only have 2x dx. So this, wait a minute. Okay, so I didn't do substitution in the previous problem. So this is negative du, right? Okay, so now when I change this integral, one extra step for definite integrals is that I also have to change the limits of integration. So my original limits were for x, but I had to rewrite it for u. When the lower limit is 0, I plug it in. 4 minus 0 is 4. Upper limit is 1. 4 minus 1 is 3. So this will become 4 to 3 u times negative du, right? Which can be written as negative u du 4 to 3, which is negative u squared over 2 4 to 3. Of course, I can do one small thing if it seems better to me. So what I'm going to do is, just to avoid this negative, I'm going to convert it as 3 to 4 u du. So the negative takes care of the limit change. So then I take this, I have u squared over 2, 3 to 4, which is 16 over 2 minus 9 over 2, right? Just 7/2. Okay. We could have done this problem without substitution also, but we did the substitution, so it's fine. Okay, so now here my u is tan x plus 3. My du will be secant squared x dx. Okay, then I do this between x and u. If my x was 0, my u was tan 0 is 0, so this is 3. If my x was pi over 4, tan pi over 4 is 1, 1 plus 3 is 4. So this will become from 3 to 4 du over square root of u, which can be written as 3 to 4 u to the power of negative 1 half du. So I take this, I have u to the power of 1 half over 1 half between 3 to 4. So this is 2 u to the power of 1 half between 3 to 4. Okay, so 4 to the power of 1 half is 2. So this is 4 minus 2 root 3. That's my answer. So my u here is going to be sine theta. Du will be cosine theta d theta. I convert between theta and u. When theta is 0, u is 0. When theta is pi over 2, u is 1. So I get 0 to 1 u squared du, which is u cubed over 3 between 0 to 1. And the answer is 1/3. So here again, my u is secant theta. Or secant x. My du will be secant x tan x. So this problem, original problem, can be written as secant squared x plus secant x times secant x tan x. So then I substitute between x and u. When x is 0, secant 0 is 1. When x is pi over 4, it is root 2. Okay, so then my limits change between 1 to root 2, and then this becomes u squared plus u du. So that is u cubed over 3 plus u squared over 2 between the limits 1 and root 2. And that will give me root 2 to the, so it is 2 to the power of 1 half. So 2 to the power of 3 halves over 3 plus root 2 squared is 2. 2 over 2 is 1 minus 1/3 plus 1 half. I don't think we need to do too much with it, but we will do a little bit. 1/3 plus 1 half is 5/6. 1 minus 5/6 is 1/6. So we can write our answer like this. Okay. Here, let u be 2y. du is 2 dy. But I have only a dy, so that is du over 2. I convert between y and u. When my y is negative pi over 12, my u is negative pi over 6. When this is pi over 8, it is pi over 4. So basically, I'm switching between negative pi over 6 and pi over 4. And this is secant squared u, and dy is du over 2. Okay, so this is nothing but 1 half tan u between these two limits. Okay, tangent negative pi over 6. So tangent negative pi over 6 is how much? It will be negative root 3 over 3, right? Okay, so I have 1 half. First, let me do pi over 4. Tan pi over 4 is 1 minus 1 half. Tan negative pi over 6 is negative root 3 over 3. So basically, I have 1 half plus root 3 over 6 as my answer. Okay, here I'm going to make my u to be sine 2x. My du will be 2 cosine 2x dx. But I only want cosine 2x dx, so I divide by 2. Then I do a conversion between x and u. When my x is pi over 8, what is sine 2 times pi over 8? Sine pi over 4 is root 2 over 2. When this is pi over 4, pi over 4 times 2 is pi over 2, sine pi over 2 is 1. So the limits now become root 2 over 2 and 1. And this one becomes u cubed plus u times du over 2. And I'm taking the over 2 outside. Then I take the integral. I have u to the power of 4 over 4 plus u squared over 2. There is a 1 half here between the limits root 2 over 2 and 1. So I keep this 1 half giant outside. I have 1/4 plus 1 half minus root 2 over 2. Root 2 to the power of 4 is how much? 2 times 2 is 4. And then 2 to the power of 4 is 16. 16 times 4 plus root 2 over 2. That is 2/4. 1 half, 1/4. So what I have here is, this is 3/4. 1/16 plus 1/4. So 4/16, 5/16. So basically what I have is 3/8 minus 5 over 32, which is, this is 4. So 12. 12 minus 5 is 7 over 32. Okay, here I'm going to make my u to be 2x minus 3. My du is 2 dx, but I only, wait. Oh, oh, wait. Okay, so here we need to do a little bit of a change. Okay, that's fine. Okay, so I will write my dx as du over 2. Okay, so keep that in mind. Then let's do this. So if you were to split this up, my original problem, what will happen? I will have 1 over square root of 2x minus 3 times x dx, right? But we have only written for dx. So what we have done here is we have rewritten dx as du over 2. Okay. Then we have rewritten this as 1 over root u. Okay. But what about this x? What do we do with this x? So for that, what we are going to do is we are going to go back here and we are going to say that if u is 2x minus 3, what is 2x? 2x is u plus 3. What is x? X is u plus 3 all over by 2. So what is going to happen is this x can be written as u plus 3 all over 2. Okay. Now I have to change the limits of my integration also between x and u. If x was 2, what is u? 2 times 2 is 4 minus 3 is 1. When x is 6, 2 times 6 is 12. 12 minus 3 is 9. So basically I have this as my problem. Okay. Now let me write it a little bit neater. So how does my problem look like? Like this. So the 2 and the 2 can come out as 1/4, and this is u plus 3 all over root u. Now this can be split up, right? We can write it as u over root u plus 3 over root u du, right? There is a 1/4 and there is a 1 to 9. So then this becomes 1 over 4. What is my root u? So this is okay. I'm going to write one more step. So this is 1/4, 1 to 9 root u plus 3 over root u du. Okay. So this is u to the power of 1 half, right? So this becomes u to the power of 3 halves over 3 halves plus 3 times this is u to the power of negative half. So u to the power of 1 half over 1 half. Okay. So then I have to substitute. So when I substitute, I will be having, wait, between the limits 1 and 9. Okay, I'll just substitute right away. 9, square root of 9 is 3. 3 cubed is 27. So I have 2/3 times 27. 2 times 9 is 18. So 9, so this is 6 times 3 is also 18 minus 2/3 plus 6. Okay. So this is 36 over 4 is 9. And then this one will be 18 plus 2, 20 over 3. That is 5 over 3. So 18 minus 5 is 13 over 3. Hopefully there are no arithmetic mistakes there. Okay. We're going to see some variations on the substitution method here. So what I'm going to do is I'm going to make my u to be x minus 2. Then my du is dx. But what is my x? My x is u plus 2. So this problem becomes u plus 2 over u cubed times du. Okay. So then I split up u over u cubed plus 2 over u cubed du, which is u to the power of negative 2 plus 2u to the power of negative 3 du, which is u to the power of negative 1 over 1 plus 2u to the power of negative 2 over 2 plus c. Simplify this. Sorry. This will become negative 1 over u, but what was u? U was x minus 2. So negative 1 over x minus 2, and then this will become minus 1 over x minus 2 squared plus c. All right. So next problem, we're going to do similar thing. We are going to make our u to be y plus 1. Okay. So then my du is dy. Now, if u is y plus 1, what is y? Y is u minus 1. Then what is y squared? U minus 1 the whole squared, which is u squared minus 2u plus 1. So we are going to do all of these substitutions into our problem. So y squared becomes u squared minus 2u plus 1 over y plus 1 to the power of 4 is u to the power of 4, and dy becomes du. Then I simplify them by separating them out. Okay, so then this becomes u to the power of negative 2, minus 2u to the power of negative 3 plus u to the power of negative 4 du. So that is u to the power of negative 1 over negative 1 minus 2u to the power of negative 2 over negative 2 plus u to the power of negative 3 over negative 3 plus c. So that is negative 1 over u plus 1 over u squared minus 1 over 3u cubed plus c. And then I substitute back. What is my u? My u is y plus 1. So when I rewrite it, I will have negative 1 over y plus 1 plus 1 over y plus 1 squared minus 1 over 3y plus 1 cubed plus c is my final answer. So same thing here. My u is going to be 3x plus 2. So my du will be 3 dx. But remember, I need only dx. So I'm going to divide it by 3. But on the other hand, I'm going to write if 3x is u minus 2, what is 2x? I have to multiply by 2/3, right? So this one I have to multiply by 2/3. So when I do all of that, what do I have? My 2x is nothing but 2/3 u minus 2. This is square root of u, and this is du over 3. So then I can take the 2 nines outside, and then I will have this. Okay. So this can be written as u to the power of 1 half minus 2u to the power of negative half. Then I take the integral. Okay. So then this becomes 4 over 9 u to the power of 3 halves minus this already becomes 4. So that becomes 8 over 9 u to the power of 1 half plus c. But what was my u to begin with? My u was 3x plus 2. So this becomes that's my final answer here. You can take a look at this. Okay. 2 more problems. Okay, same things. The logic is the same now. My u is going to be 3z plus 2. My du is 3dz. But I only want dz, so I divide it by 3. So this is something I keep together. Now 3z is u minus 2, right? But I just want z, right? So I'll do u minus 2 over 3. And then z plus 1 will be u minus 2 over 3 plus 1. So then what will happen here? I will have uh, u over 3. This is minus 2/3 plus 1, that is plus 1/3. This is replacing z plus 1. And then this one is u to the power of 1/2. And dz is du over 3. I distribute it, then I will have u times u to the power of 1/2 is u to the power of 3/2 over 3 plus u to the power of 1/2 over 3, and there is also a du over 3, and that du over 3, the 1/3 can go out. Okay, so then I take the integral. I will have u to the power of 5/2 over 3 times 5/2 plus u to the power of 3/2 over 3 times 3/2. Simplify this. This will be 2/15 u to the power of 5/2 plus 2/9 u to the power of 3/2 plus c. And what was u to begin with? My u was 3z plus 2. So I have 1/3, 2/15, 3z plus 2 to the power of 5/2 plus 2/9, 3z plus 2 to the power of 3/2 plus c. It might be a good idea to take the derivative of this and check your answer. Okay. All right, so here let us make x squared plus 1 to be u. So 2x dx is du, but I want only, okay, so what I'm going to do here is I'm having x squared plus 1 to the power of 10 here, and I'm going to split up this x cubed as x squared times x dx. So which means this x dx will be written as du over 2. Okay, so I have taken care of the x dx. But what about the x squared? Now the x squared can be written as u minus 1. So now what happens to my problem? U to the power of 10 times u minus 1 times du over 2. So which means the 1/2 can go out, distributed u to the power of 11 minus u to the power of 10 du, which is u to the power of 12 over 12 minus u to the power of 11 over 11 plus c. And what was u again? X squared plus 1. So I have 1/2 x squared plus 1. X squared plus 1 to the power of 12 over 12 minus x squared plus 1 to the power of 11 over 11 plus c.